Hello everyone, welcome to another tutorial on graph neural network. So this is a very basic tutorial I'll be giving you today about graphs, and this is the first part. The first part is that how you can build graph using something called NetworkX. So Network is a popular package in Python, which you can use to construct and draw graphs that are undirected or directed with unweighted and weighted edges. So I'll show you that how you can build a graph using NetworkX. Then how to add nodes, how to add edges. Then how to find degree, and few basic questions like whether there is a path between two nodes, or whether there is a shortest path between two nodes. So that will be kind of the first part or the content of this tutorial video. So let's get started. So before starting, let me show you that if you are not familiar with this environment, this is called Google Colab. So if you have a Gmail account, this comes as a free, and Google typically gives you these things. It gives you a CPU and a T4 GPU, and but you can run in Python or R. These are the two programming language that is available. But typically, we use Python for running our codes. Now, if you are doing basic Python computing, then CPU is sufficient. But if you want to run deep, neural network models and all, then you need GPU. Now you can connect it here. Just clicking on the reconnect or connect, you can connect it because I've already connected last day, so it's showing me reconnect. But if you are coming to this interface for the first time, maybe it will show you connect. Okay, now it's showing that it's already connected. Now you can check that there, whatever the server that they're giving, the RAM size is 12.67 GB. So 12.67 GB RAM they're giving, and they have given you around 108 GB of hard disk. So this compute engine or compute server that Google Colab is providing each of their user who has a Gmail account. Now in this, this is kind of a Python notebook. So if you are familiar with Python notebook, then you will see that there are a lot of cells to write your code. But also there is so there are two cell probably you can see here. So if you click on code, so this is just to write the code. And if you click on text, then this is to write the text. So this is for text purpose. So you can see the text in the thing, and there are a lot of things you can do. You can put headings, and there are a lot of other things you can do listing. You can bold it, italic it. So the basics of text processing is there. Whatever you are getting in words. And there is one more thing that is being added recently, that you not only start writing your code, you can generate your code using AI. So they have incorporated this. Google has incorporated this Google Colab with Gemini. Gemini is one of the popular AI tools that they use. So you can generate your code also. I mean, I haven't tried it, but you can any day try. It's like ChatGPT. Okay, so that was the basic idea about Google Colab. So I would recommend all of you to check. You just type in Google Colab, and this this interface will be open up. You have to just create a new file and you have to continue. Now coming back to the topic of this tutorial. So as I said that we'll be using this popular tool or popular package called NetworkX to build the graph. So before you use the NetworkX in Python, what you need to do is you have to import that package. So you're importing NetworkX as NX. That means this package you have imported and given its name as NX. So this alias name we'll be using for doing all of our tasks. Now, for example, that I want to build a new graph. So the command is that nx.graph. So if you write nx.graph, that means networkx.graph, then it will return you a object of type graph, and then just print g. Oh, just a minute. I have to first run this one because the first import has to be done. And then suppose if I run this, so see, so g is a object of networkx class dot graph. Okay, so this has been done. Then suppose we want to add a node called e, whose name is add a node whose name is e. So you can just do g dot add. Okay, now suppose I want to add more nodes. So this is the command to just add one node. But suppose we want to add more nodes like B, C, and D. We have to add. So then what we have to do is that we have to add. We have to take a list nodes to add. This is a list which contains B, C, and D, and this list we can pass here G add nodes from. Then we can pass the list. So so for example, okay. Before that, let me show you that how this graph looks like. So this node A is added. So then how to visualize is init.draw. So this is the command to visualize the graph. So if you just write init.draw G and width levels true, then it will show you the graph. So see, there is a one node and the level is created at A. So if you don't need this level, you can put it false. Okay, there is no level is stated. Okay, so this is just to visualize the graph. Now, for example, we want to add more nodes. So let's copy this. All right. Let's see now. Now see, there are 4 nodes added, A, B, C, D. So let's levels. Okay. A, B, C, D. The 4 nodes have been added. Okay. Now, suppose you want to add a edge between them. So suppose you want to add between A and B. So the command is g.add edge A, comma B. So suppose we add it. Now let's see what happens. See, between A and B, there is an edge, but A, B, A to B, A to C, B to C, these are not yet connected because just one edge I have added. So the command is to add more add edge, just to add one edge. Now again, if you want to add more edges, the command is again like similar. So you have to create a list like AC. So these are the edges. Suppose you want to add AC, BC, and CD. Then you have to take a list of all the edges and then add edges from. So similarly, there are add nodes from. It will be add edges from. So suppose you want to do that. Now see all is connected. See all is connected. A is connected with B. A is connected with C. B, C. So this is how you can build a graph. You can take an object of a graph that is the kind of the empty object. I mean, nothing is there in this graph. Null graph it is end of a null graph. Then you can add one by one nodes, or you can add all the nodes you can add together using any of these 2 commands. Similarly, you can add one edge, or you can add more edges at a time, and then you can visualize. So this is a undirected graph. Now suppose if I have to do a directed graph, then what I have to do? I'll be doing the same thing, but I want that these edges are directed, A to B, A to C, B. This is undirected edges. So simple thing that you have to do is that you have to change this to digraph. Sorry, it will be D graph. D graph is for directed graph. If you just click it, now you will see that these are directed edges. Now the edges are directed because you have taken directed graph. So edges will be A to B, A to C, B to C, and C to D. You can check A to B, A to C, B to C, and C to D. So this is the simple, there are these 2 simple commands. If you are taking nx.graph, it is a undirected graph. And if you are taking a nx.digraph, it will be a directed graph. Okay. Now, there are many ways to actually visualize this nx.draw. So for example, this is one more command. This is a simpler one, but you can try out this one as well. So width level means again, the level will be there. But node color, if I want to change, for example, if I want to make it yellow, if I want to make the size of this node bigger, then you can obviously put node size as a bigger size. Front color here it is black, but if you want, you can make it white, and font size also you can increase. For example, if you run it, you see, oh sorry, so suppose this is blue. Yeah, you see, node colors are now yellow, node size has increased. The front color is, I have put in blue, so the A, B, C, D front color is blue. So this is how you can do the simple, simple part, simple build. You can do simple graph creation like this. So this is the first part. Now suppose, okay, let me again run this one. So this was the same thing. Okay, so this was the graph. Now suppose if I want to say what are the nodes are there in the graph and what is the number of nodes. So that the command is g dot nodes will return you all the nodes that is there in the graph, and g dot number of nodes actually give you the what is the number of nodes that is there. So for example, if I run it, so these are nodes A, B, C, D, and number of nodes is 4. So this is, simple command you have to do. Similarly, suppose you have to list all the edges and what is the number of edges, then you can try this. These are all the edges that is there, and what is the number of nodes? G dot number of edges, that is also 4. Now, for example, now there is a notion of neighboring node in graph. For example, C is the node. What are the neighboring nodes of C? Suppose B is a neighboring node, A is a neighboring node, D is a neighboring node. That means all the nodes that is connected or that is adjacent to a particular node, that is called a neighboring node. So, for example, I want to know that who is the neighboring node of C. So, what is the command? So, the command is this: G dot neighbors. So, for example, the node B I want to. So, here the neighboring node B is C or C and A. So, if I run it, so the A and C. Suppose if I change it to C, then it will show you A, B, and because C is kind of a centered node. Okay. Next, suppose I want to check whether this graph is a tree or not. So for a graph to be tree, there shouldn't be any cycle in the graph. So if there is a cycle in the graph, that means the graph is not tree. So here you can see that there is a cycle in this graph. B, C, and A, that forms a circle. So that's why this will not be a tree. So the simple command is nx dot each tree. So it will just, if you just put the cursor here, then also you can see the definition of this particular function. So say that each tree returns true if G is true. A tree is connected graph with no undirected cycle. For a directed graph, G is a tree if the underlying graph is a tree. Okay, so that is kind of a definition. But this function, it returns true if the graph is a tree. So let's see. It's false because there is a cycle here, so it's not forming a tree. Okay. The next is the okay. Let me change a bit. So for example, this edge, if I remove A and B edge, if I remove, suppose I remove this particular edge and I run it. Okay. Now if you run this one, you will see it's true because this edge has been gone, so the cycle is broken. So now it's a tree. It's not it's a tree now, and there is no cycle. So that's why this graph is now a tree. Okay. And finally, whether the graph is connected or not. So a graph will be connected if in any two pair of paths, a pair of node, there will be a path. Then it's called connected graph. And if there is no path, suppose two node is there which is not connected, then the graph is also not connected. But here you can see that any two node, if you consider, then there is a path between it. So that's why this graph is connected. So if I check it, then you see it's connected. But for example, if I add another node here, which is, for example, F. Okay. And F is not connected to any of them. So you can take any pair of node like F and A, and there is no connected path between it. Then, if you now check whether it's a connected or not, you'll see it's false. Okay. The minute I have no plan it, okay. And the final thing is that, if you have to check the degree of a node. So, for example, I want to check the degree of node C. So what is the degree? Degree means that how many nodes it is connected with, that how many neighbors it has. So C is connected with D, A, and B. So, for example, if I want to check the degree of C, it will be 3. But for example, if I want to check the degree of B, you can see that B is connected with A and C. So then it will be 2. So these are the few simple things that you can immediately check after building the graph, and there are many other things also you can do. The next is path. Path means that whether there's a path between D and B. That means whether D or B are connected, and you can start with D and you can reach to B by traversing the nodes. So that is called path. So for example, again, I'm forming a graph here. So for example, this is my graph, and I want to check that whether 3 and 4 has a path between it or not. So for example, 3 and 4, whether there is a path between 3 and 4 or not. No, definitely there is a path between 3 and 4, 3 to 1 and 1 to 4. So this nx.hatch path, that is the command, and you have to give the graph and the pair of nodes, and it's true. You can list all the simple paths between 3 and 4 by this command, nx.all simple paths. So you can see that between 3 and 4 there are many paths. 3, 1, 4 is one path, and 3, 2, 1, 4, that is also a simple path that is also available. So if you just write this list of nx all simple paths, then it will show you all the paths. Okay. Now the question is that what is the shortest path? Whether this is the shortest path or 3, 1, 4 the shortest path. So that you can try out with nx.shortest path. So you see 3, 1, 4 is the shortest path. But for example, if we just add another node here, suppose this is my graph, that 5 is not connected, and suppose if I want 3 to 5, whether there is a path between it or not. So if you will say there is no path, and if I do it here, then also you will see there will be no path. This is null. The 3 to 5, there is no path. That means that's why all simple path, that is the null set it will be returning. And finally, the shortest path, again, if I do 3 to 5, I think it will show you some error. Yeah, it will be showing you some error, and the error is there is no path between 3 and 5. Okay. Got it. Finally, connected components. Connected components means that if the graph is not connected, for example, this graph, if the graph is not connected, for example, if I take 5 and 6, and suppose if I add here one more, 5, 6, then you will see here all the nodes are not connected in the graph, but there are two components. This is one part of the graph which is connected internally, and this part is also connected. They are internally they are connected, 5 and 6, but they are not connected with the other parts of the graph. So this is called connected components. How many connected components is there? That means there is two connected components there, and connected component is only available if the graph is not connected fully, and if the graph is fully connected, there is only one connected component. So for example, I take this one. Okay, there are two connected components. Now, again, if I want to check that each is connected, so each connected and the graph you have to pass, and it will say false, it's not connected. Now, if you want to, see how many connected components are there, then it is number of connected components, nx.number of connected components. This is the command you have to pass. You can check. It returns the number of connected components. So it will return you 2. There are two connected components. And what are the connected components? Again, you have to put a list of nx connected components of G. And yeah, these are the two parts of the connected component, 1, 2, 3, and 4, 5. So that ends up the first part of this tutorial. And I hope you got a basic overview about how to use NetworkX to build a graph, and to check a few things like whether there is a path between two nodes or not, or what are the number of nodes, what are the number of edges, what are the exact nodes and edges, that also you can check. What are the neighbors, graph is tree or not, graph is connected or not. So these are simple question. Degree you can check, obviously. Connected components you can check, whether there is a simple path, shortest path. So these are very basic questions you can easily answer using these packages. You have to just, give input, or you have to just build the graph as you want. And you have to just, with simple commands, you can get the answer of the very basic questions that you have.